Okay. Um, Hi everyone. Welcome to this call. Welcome to this event titled Explore Git, GitHub, Codespace, and Copilot. So before we get started, I just want to remind you of Microsoft Student Ambassadors Community Guidelines. So please be reminded of our code of conduct. On this call, please be welcoming, be respectful and inclusive, be friendly, be open and patient, acknowledge differences, be thoughtful, and of course, be kind. All right, so I know you might be wondering that why am I having introduction to version control system? Because the title says explore Git, GitHub, Codespace, and Copilot. Well, actually, version control system is a program or set of programs that tracks changes to a collection of files. It turns out that GitHub is or Git and Git precisely is a type, or it is one of the version control systems available out there. So in I did not just want to rush down to explaining what Git is. I want you to understand the concept of version control system, which Git happens to be one of them. There are other services that software and services. There are other software that provide version control. GitHub turns out to be one of them, and arguably the most popular one. So, like I said, a version control system helps us to track changes to a collection of files. Another name for a version control system, or VCS for short, is SCM, which means Software Configuration Management System. So you might be wondering who uses version control system. So version control system is used by variety of professionals, um, including software developers, data scientists, data analysts, project managers, open source contributors, and a lot more. So why are we stressing about this version control? Why does version control matters? Like I said, I'm tempted to say the most important reason why emphasizing on version control is tracking changes. But that's not actually all, because aside tracking changes, you could collaborate, you could leverage on the reversion feature and many other features that are available with version control system. So what's up with these tracking changes? So a version control system helps you to keep track of changes that happens to your files. It helps you to keep a record, and with that you can easily recall or obtain earlier version or previous version of that file. Let's say you're working on a file on so time, you updated let's say you updated 2 lines. In the next minute you updated line 3 4, then you updated line 4 5, and like that. So you get history of how those changes were done and even who made those changes if you are collaborating with anyone else. So you get a full history of all those changes. So you can easily, okay, I'm already talking about reversion now, but you can easily assess all those changes at any time you want. So that is the feature, which is tracking changes. Another advantage of this VCS is collaboration. All right, so it allows you to collaborate with several team members. It gives you that capability to work on the same file at the same time without affecting each other's work. Imagine a situation whereby you and someone are trying to work on the same file at the same time, you know, when, let's say, for example, you guys, okay, let's say you're working with a document and the introduction says, hello, I'm a boy. Then the other person at the other end maybe feels like that too plain or something, and changes that to, hey, welcome, I'm a boy. So in that case, you would lose that details, even though now with Microsoft Word, I mean 365 packages, you also have this feature incorporated into them. Now you have these features whereby you get to track changes also, but that's the idea. So without this version control we are talking about, then that wouldn't have been possible. Then another reason why we are emphasizing, or why we are talking about version control system, is the reversion. Yes, it allows you to go back to the previous state of any file. You could go to any state you want, maybe the version 1, the version 2, at any point. So it's quite easy to do that, and you would see that in next couple of slides and demo. All right, so what is Git? Let's get into business now. So Git is a fast, versatile, highly scalable, free and open source VCS. Remember, VCS is a version control system. So I would keep repeating VCS just to save time and for short. All right, so Git's primary author is Linus Torvalds. Is also the creator of Linux. So Git is distributed, which means that a project a project's complete history is stored both on the client and on the server, meaning that you have access to your project on your local computer, and you also have access to that on the cloud. So it is distributed, it is two in one, more like hybrid. You have online access, and then you have cloud access or online access, to put it that way. So you get to edit your files without network. Let's say, for example, we all experience network troubles, especially in Nigeria. So while working on your projects, connectivity is bad, so you could just leverage on the local version of your project. You don't have to wait. Connection does not have to delay your development, your production, your creativity, and all of those ideas. So you could leverage on the local on your projects, which you have on your local computer, work on that, and when connection is back, you can just upload, you can push that to the cloud. Um, you can push that to the server, to GitHub server. So that's how it works. So you get to have a local copy of your project, and then you still have the online version. The online version obviously gives access to other users to collaborate, to yes, to collaborate, to share. Yeah, it makes sharing easy. Unlike you know, uh, without this kind of system, we would have to maybe um, zip those files and send them out, which would in like logically be large. But with Git, you don't have to do that. You just put them online, and anyone can have access to those files without troubles. All right, so for this event, I won't be talking about Git installation because I'm trying to keep to time. But if at all you don't have Git on your computer right now, you can go ahead to click on this link. This will direct you to GitHub, sorry, to Git download page, where you get instruction to download Git, and you also get the executable file to install Git. But if you have any issues with that, you can just reach out to me. I would provide you guidance that I can, and or probably send you YouTube videos that you could watch. Yeah, you could just watch that on YouTube. So it's quite easy though and straightforward. But if I thought you have any issues, just you could reach out to me. I'll be glad to help. All right, so that was it. Now, what is GitHub? GitHub is a cloud platform that uses Git as its core technology. GitHub simplifies the process of collaborating on projects and provides a website. Yes, Git provides a website. Then you also have more command line tools and an overall flow. that developers and users can use to work together. Yeah, GitHub makes the whole thing seamless. So GitHub is built on Git. So GitHub is built on Git, which is like the core technology here. So it also has more features like the collaboration, the command line, more command line tools, and a general flow, which would see very soon. All right. So there are some key features provided by GitHub. These are just a few, just to mention a few. So we have issues. This is a feature whereby you can, maybe when you have issues with a project, you could just raise those issues alerts using the issues um, feature. Then you also have discussion. It's like a chat zone whereby you get to talk to the developers and maybe all contributors of that project. Then you also have pull request, which would talk more about soon. We also have notification, we have labels, we have actions, we have forks, we have projects. All right. So let's talk about the component of GitHub Flow. Now, but okay, let's first off, what is branches, or what are branches rather? Because these are common stuff you would hear me say, or you would hear around GitHub professionals, or you would hear in the GitHub space. So let's just talk briefly about these things. So branches are an essential part to the GitHub experience, because they are where you can make changes without affecting the entire project where you're working on. You can think of it this way, like a tree with two branches. So you let's say you have a project that you have running and working, right? And your customer or your client somehow needs maybe a feature to be added, or some kind of bug that needs to be fixed. So you could make a copy, you could say a copy, literally a copy of that you know working project, and make a branch of it. Then you could work on that new branch, which gives you access to test. In fact, you can say safe testing, because in this new branch, why while trying to fix or implement that idea, or the fixing the bug, you could break that code. But this is what GitHub saves you from. This is what branching saves you from. So instead of affecting and getting to a point whereby you've broken your code, you don't have to do that. You can just make a branch from that existing branch and build off it. Then you implement your idea, fix the bug, and then just merge it together. We'll talk more about that, and we'll talk about the right terms. I don't want to go too far for now. So your branch is a safe space to experiment with new features or fixes. If you make mistake, you can revert your changes, yes, or push more changes to fix the mistake. So that's it. It's quite interesting. It gives you that leverage to safe test, so you don't have to break anything. All right. The next one will be commit. So what is commit? A commit is a change to one or more files on a branch. So, like I said, you were trying to implement a new feature, or you are trying to fix a bug. When you make those changes, you commit them, right? You make those changes, and then you more like, okay, oh, I've made these changes. You submit them to be saved, right? You save them. So that's what commit talks about. And every time you submit, a commit is created, it is assigned to a unique ID that can be tracked. Yes, it is tracked, and a unique ID, more like an hash code, whereby you can get you could use to distinctively identify each commit. Then you also have access to the time the commit was made, and who made the commit, and all of that. So commits provide a clear audit trail for anyone reviewing the history of a file or linked item, such as an issue or pull request. All right, we'll get to see that in demo. I know sometimes explaining these terms can be they can just be one kind, but would see them in action, and I think that would really help a lot. All right, so another one is pull request. A pull request is a mechanism used in GitHub to signal that the commits from one branch are ready to be merged to another branch. All right, so going back to that illustration I was using the other time. So let's say I've fixed that bug, or I've implemented a new idea, right? I commit my changes, then I submit a pull request, meaning that, oh, I'm ready to make those changes. I've tested on my on that new branch I created, then I see that it's working, like nothing is broken. So I can now match my change on that new branch to the main branch, hence pull request. All right, so this image illustrates and explains the GitHub workflow. That everything I've been trying to explain earlier on, this chart kind of puts them in a cool way to understand. So let's take a look at it together. But before that, the GitHub flow can be defined as a lightweight workflow. It's quite lightweight because it could be complex. Yeah, a lot of things could go in between this, but this is like the most basic, and indeed it's just, in fact, this explains it more clearly. All right, so like I said, it allows you for safe experimentation. So you get to test your new ideas, you get to collaborate with your teams using branching, pull requests, and merging. All right. All right. So from here, let's these points highlighted. Let's say this is my main branch. This is my main branch. That term main is just a term that is just generally used. It could be any branch, like you could literally call your branch anything. So, but main is just the convention. So this is my main branch, and from this main branch, then I branch off to make another branch. Because I'm trying to implement a new feature, I'm going to call it a feature, like calling that branch feature. Again, that could be anything. So um I just branched feature from main. Like I just created a new branch which I called feature from the main branch, right? I hope that's clear. Then um from here now, I can go ahead to make my changes. So this is a change. This could be another change, and this could be another change, and all of that. So you make your several changes. You could make your change. Someone else you are collaborating to can also make those changes. And once you are done, you are okay with the project, then you can now go ahead to submit a pull request. So this is that point. You get to submit a pull request. So at this point, you are saying, okay, I've checked my commit. My commit is fine, and I'm ready to move those changes from the feature branch to the main branch. At this point, you must have tested that your code works. All right. I'm so sorry. My network was lagging. Please confirm you can hear me.
I can hear you.
All right. Thank you very much. Um, So at this point, you submit your pull request. So I was saying that your pull request indicates that, okay, I've tested my code, nothing is broken, it works. So the idea is implemented, so I'm good to go. So at this point, let's assume that you are collaborating on this project, or let's say it's an open source project. So you have opportunity to discuss this point, a discussion point. So you could discuss, communicate with the let's say the owner of the project, or yes, the managers of the project, that, hey, I just try to implement this feature or fix this bug. And at that point, they would look into it and try to see what you've done, and if it makes sense and they are cool with it, then they get to approve your request. And at that point of your request being approved, then your changes will be merged to the main branch. So you are back to this point now. So your changes are now pushed to the main branch, and this feature branch is deleted. It is advisable to delete it because there's no point keeping a duplicate of because now your main branch is now having the same content as your feature branch. So ideally you should delete that. And if at all you need access to it, or you're wondering that your main branch might get updated in the future, but you still want that feature branch for any reason, you can still get that back. Remember, we talked about everything being recorded, that you can always revert, so you still have access to that. So ideally you should delete the branch once you are done and the uh, changes are committed to the main branch. All right, so that's the that's the GitHub workflow. So go ahead now. All right, so like I was saying, I mentioned few terms earlier, but turns out there are more. I'm trying to make this class you know should I say, yeah, I'm trying to make it engaging so that you understand me when I talk about these things, and you probably hear it around GitHub experts, professionals. When they talk, you'd hear them say most of these terms. So what do this term means? So that's what we'll be talking about here. So the first one on the list is repo. You would hear developers say repo, share me the link to that repo, I'm creating a new repo. So what is a repository? Yeah, a repository, or repo for short, is essentially a storage location where Git track changes to your project files over time. You could see it as a directory, right? Like a folder that houses your files, even maybe more subfolders and like that. So ideally, a repository is a directory. All right, that's clear. Now the next one is clone. All right, you would hear people say, I'm going to clone that repo. So when we say clone, what are we talking about? So when you are cloning a repo, it means that you are downloading a copy or the files in a repository to your local computer. So that's the idea. You have some repository on GitHub, you are trying to get them on your local computer. So the word clone. So from there, we also have fork. Fork is very similar to cloning, but the difference here is that when you clone, remember I said you are making a copy, you are downloading files on a repository to your local computer. But in the case of forking, you are making a copy of a repository to your GitHub account, not your local computer this time around. So that's just the difference. Both of them, you are making copies, but when you're talking about clone, or when you should use clone, the idea is that you are getting those files to your local computer, but when you fork, you are getting those files on your GitHub account. So that's on the cloud. Why cloning, you get it on your local PC. Then the next one is branch. I know I've talked about branch earlier, so I just want to emphasize that branch is important. Like that, it's one of the powerful things with GitHub. So a branch in GitHub is a separate workspace within that folder, right? So remember that tree analogy again. So that's the idea of branching. All right, and remember I said that name main is just a convention. You could literally call your branch anything. You could call your branch anything else, but that main branch is just a convention. And if at all you try creating your branch on Git, like the command line terminal, you'd probably see stuff like master. So that's possible too. So another thing is the readme.md file, which is a markdown file. Is a file that serves as the introductory guide and documentation for your GitHub repo. So in that file, you get to introduce your project or your idea, maybe uh, um, challenge you are trying to solve, maybe your motivation, what inspired you, how you came about your solution, and even explain to other developers that might want to run your project how to go about that. So that file is very essential in GitHub. And another file is the .git ignore file, which is a configuration file that specify files and directory that Git should ignore. All right, so more like when you are pushing code from your local PC to the cloud, there are some stuff you shouldn't share, like you shouldn't push online, right? Stuff like private keys, dependency. If you've ever worked with Node.js and stuff like that, you'd know what I'm talking about. So you don't have to upload all those packages to your Git. That would be very heavy, and that's not necessary because any developer that wants to replicate or build on your project could just read your README guide and also replicate the development environment. All right. So the next thing we'll be talking about is license. So a GitHub license specifies the terms under which others are allowed to use, modify, or distribute your GitHub project. Sorry, your project code. So if you are familiar with the um open source project, you'd know more about license. So it's more like, hey, you can use this, but you can't do this. You get to use this, maybe giving credit back to this, all of those are in the license file. Then there are a lot of them. These are just basic ones. I feel like you really need to get on working. So there are a couple ones that I highlighted here. I think we've talked about commits. We've talked a bit more about pull requests. We've talked about a bit about merge. We'll still talk about that and see it. So there's also remote, there's conflict, there's staging area, and all of that. You could just make research to read up more. But with these basic ones, you'd be good to kickstart. All right. So why coming up with the idea for this class, I figured out that it would be boring to just talk. So I will be doing some demo um while trying to explain a few things here. So on this page, I will talk about Git commands, more like more like instructions you can give Git and Git understands and would do those things for you. All right, so instead of me explaining all of this, reading through the slide, I would just switch to my terminal. Like I would take off this screen now. I'll stop sharing my screen and share my terminal screen instead. So for a while you won't see anything, but I'm coming. Let me open up my Git. Again, if you don't have Git installed, it's fine. You could just check YouTube. If you don't still get, or if you have any issues, you can just reach out to me. I'll be happy to help. All right, so all right, you should see my terminal, just a black page up now. Please just confirm you can see that. Let me be sure. Though you should see it now, but let me just be sure we're on the same page. Okay, thank you, Ibrahim. All right, so since you can see my terminal, so I'll just go ahead to run those command so you see what it looks like and understand what they do. So the first command I'll be talking about is the git help, git dash help, which is like the most important, I believe, because if you enter this command, you get to see this long list of instructions. This is like a guide on the things you can do with Git and more like a manual, right? So usage, you can say git dash v or dash version. You can say git this, and it's, if you even come down, you see that it's telling you more interesting stuff like clone. It tells you that clone a repo into a new directory. Init, create an empty Git repository or re-initializing an existing one. Add file. So it gives you this kind of list of the things you can. It's more like your lookup guide or manual to. So anytime you really need to look up something, you can just come here straight up. You get access to that. So the next on the list is the cd command, which is like a directory, right? Sorry, change directories. The cd command means change directory. So remember we said directory is directory is like a folder, right? So right now I'm trying to go to a folder on my local computer, but I don't have that folder yet. So I would use another command, which is like the third command now, which is mkdir. So this command creates a new directory, right? It creates a new folder literally. So, but before I do this, I will go back to use that cd because right now I'm on my C drive. I'm in the user folder, so I don't want to create that new folder here. Instead, I want to create that folder somewhere else. So to do that, I can use that cd we talked about. So if I type cd, then okay, let me just do this. Let me copy all of this. So cd, paste all of that, then /desktop, because I'm trying to go to my desktop. All right, now nothing happens, but if you look at this prompt, you see that initially it was just C user permission lexi, but now you have all of that, then desktop included. All right, so that tells me that you are now on in your desktop folder. So from here, I can do that other command I talked about, mkdir, which is like to create a directory. So I'm going to create a directory called live demo. So this should create a new folder for me. In fact, let me share my desktop. So I'll stop sharing the screen and share my desktop ASAP. Coming just a minute. Okay, before I do that, let me okay, I want to share my desktop. I think that's so that you see that folder. All right, so let me see. All right, I'll do this instead, I think. All right, from here I would go to my desktop, and in my desktop you should see yeah, this guy, live demo. This is the folder I just created. I know you would say I could have done this, create new folder and just create folder. Well, that's still exactly the same thing, but I just did that with the terminal. So with the command line. So this is the folder we just created, and we'll be using this. So let me just minimize it, then go back to sharing that terminal screen because we are going back there. All right, so back to the terminal now. Let's do some other commands. Now remember that when I created that folder, when I showed you there's nothing in it, like there's nothing inside, it's just a blank folder. So I'm going to go back to my terminal now. Then I would use the next command, which is git init. Git init. So git init initializes a repository. So if I click on that, then nothing really happened, but something happened. So again, let me quickly switch to that folder to just show you that something really happened. So I would just a sec. All right. Okay. Start it. Let me refresh that. Okay. Initialize empty. Okay, okay. All right, no problem. But I know it would. All right, so I'll just continue with the terminal. So on the terminal, I'm going to type in git status, which kind of tells me about the status of okay, my bad. I actually did something wrong. Remember, I created a folder. Yeah, I created a folder, a new folder, but I didn't navigate inside that folder. So that was why I didn't see what I was looking for earlier. Right. So I'll just quickly do that. So I'll do cd live demo to go inside of that new folder I created. Yes, live demo, and enter. So now I'm in that new folder. You can see I now have live demo here. So now I can run that git init command. Git init command. If I run that now, yeah, I should have something in my folder. Let's confirm that. But I should have something in our folder now. All right, so we have this folder, an hidden folder. If you don't view hidden folder, like if you don't have hidden folder set to be shown, you might not see this, but it's fine even if you don't see it. So you have all of this stuff here. So we'll just go back, then I'll go back to my terminal. I just wanted to show you that. So going back to the terminal, we can continue with the status command. All right, so if I want git status now, okay. If I want git status now, I get to see that I have all right. So this is what I was talking about because I created this with Git. So I have my master branch, my branch called master, not main in this case, but that's fine. I can rename it, I can create a new branch and all of that. So I have no commit yet, meaning that there's no change I've saved, right? There's no change to this folder yet. So, but now we have Git initialized in that folder. So from here, what else can I do? Well, I can choose to add files. In fact, I'm going to do, okay, I'm going to, I have just lightweight pictures here just to explain. So I have lightweight pictures. So I will quickly share my screen again. So from here, I would go to my desktop and copy these images. So I'll copy these images, then I'll put them in this folder. Okay, actually, okay, let's just do it that way. Because you could actually do this with the terminal, but either ways, let's just do it this way. So I've added these three images to the repo. So I can close this now and go back to my terminal. So going back to my terminal, if I try to see git status now, let's see what happens. So when I run git status, right now I have three red files. Red files meaning that nothing is committed, but I've actually added stuff. So I've added these three files, but they are not committed, meaning that I've not staged these changes. Like these changes are untracked, right? So that's the idea. So to do that, like to make them track, I could just I could add them one after the other. I could say git let's say copilot git add copilot.png. So that's like, so that just added this image. Let's do git status again to see. So now we see that we have one green file, meaning that this file is now being tracked, is added, but these other two are not added yet, but they are not tracked yet, but they are actually in that folder. That's the correct term to use. All right, so I could go ahead to start adding them one after the other, but that's like trouble that's tiring and all of that. So I could just use another command, adding instead of git add and the file name, I can say git add dot, which means that I'm adding everything in this folder. So if I run that now, then I run status again, Now I have 3 green files, meaning that I now have these 3 files added and staged. All right, so that was explaining git add. So next we could do git commit. Remember, committing is like the you submitting the changes actually. So here now, that's what we're about to do. So we're about to submit these changes. So we are going to say git commit. You could just enter git commit, and it would prompt you to enter a commit message, or ideally you can just do it at once by adding -m and then the commit message. Let me say add, oops, nope, that's not it. This add, let's say add pictures or images, add images. So that's my commit message. And now it says that 3 files change, 0 insertions, 0 deleted. So I have so these were the files I've created. I've created 3 files. Then these are now staged, like they are submitted. We could remove files. We could remove any of them by using git rm. Let's say remove that copilot.png. So if we do that and run, let's say status again, we see that I've deleted that and that file is deleted from that repo. But if I want to add delete all, I could use that remove dots again. But that's not interesting. That's not what we'll be doing. So let's go ahead. Let's do git log, which kind of displays commit log. So all of the things we've done, right? So we remember we talked about all of these changes being tracked, that I said you have access to the time it was the changes were made, who made those changes, and all of that. So this is what we're talking about. So you get to see the author who made that change. In this case, it is me. The date I made that change, the time. Then this was my commit message, right? So you get all of those things kept somewhere for you, so that you can easily access. So the last command which I'll be showing or talking about now is the git push, which is like, let me not say the biggest, because actually it's not the biggest. There's no biggest actually. So ahead of this event, I created a repo for this. I created a GitHub repo. So I just want to quickly share that. All right, so this was the repository I created. So I it's titled live demo also, just because it's a live demo. So when you create a new repository, empty by the way, like a blank repository, so you get these instructions. So you've seen within there's no readme file yet, so there's no point echoing the readme. But you saw me did this git init. You could add this. Remember we used git add copilot.png. So you also saw me use this git commit blah blah blah. So let's go ahead. Remember I said my branch was main was master at the other side. But if I want to change it to main, in fact, let's do that. Let's do that. Okay, you know what? Let me just explain from here, then we'll do it at once at the terminal. So I could create a new branch from using this command. Then I can add a remote, meaning that I need access to this repo on GitHub. So this is this repo on GitHub. Then I'm connecting this repo to my local repo. That's actually what I'm doing here. And this line, I'm pushing codes or whatever files I have on my local machine to this online repository. So that's the idea, and that's what we'll be doing now. So quick off, I would close the screen again and go back to my terminal. So would continue. I would push this code, right? I'll push this code. So I'll share this repo. You can also look at it from your hand, because that's one of the features, right? We talked about easy sharing, collaboration, and all of that. So from here now, you should be able to see my terminal. Right, you should be able to see my terminal now. So I'm going to go ahead to create a new branch. So I just copied and paste that. So I've created a new branch. Now, if you look at this now, I have okay, yeah, it won't really display a lot like that. So I'm going to now add my remotes. So if I paste that in, remember again, the idea here is git, which is like the base command, remote, add, origin, and this link, you get this link on your GitHub from GitHub. When you create that repo on GitHub, would still create another repo. So you see how to get this link. But you could also get this link from that page I showed you. Because when you create a new repo, you get that page. So when I click on enter, okay, so when I click on enter, nothing much happened, but something actually happened. So we move to the next one, which is to push. So we when I paste this and push this code now, then at this point you might get a prompt asking you to sign in. Yes, you might get a prompt asking you to requesting for your email and password to sign you into GitHub. So you could just enter that, but I'm already logged in right now. So the pushing is done. We have pushed items. So we have 100% blah blah blah. So I'll go back the to the GitHub page now to show you that our pushing is live on GitHub. So all right, so if I refresh this page, let's see what happens. All right, so when I refresh this page, I have this now. That previous page is gone. Now I have these three files I added, so we could see them. Just click on them to view them. So we have this image that you saw on my local computer the other time. We have this Copilot image also. Then we have this GitHub image also. So interesting. We've successfully pushed our files from our local computer to GitHub, which is like the cloud, yeah, the cloud version. All right, cool. So let's go back to the slide now. Sorry, okay. All right, the slide should come up in few seconds. All right. Okay, so that was GitHub command, and certainly, like when I ran GitHub Git help, you saw that there were a lot of command. I just picked these ones. These ones, if you actually know these ones, like I feel like you'll be good. In fact, if you know this Git help, like you are good because you can just look up whenever you want to, and as you use it, you would just recall, you would like remember them. And if you want to look up like the full list of commands you have, you can click on this link. This would direct you to GitHub documentation page, so you get access to the full manual, to the full documentation rather. All right, so again, I won't be talking about signing up a GitHub account. That's quite easy to do also. If you don't have a GitHub account yet and you want to create one, just click on this link. Don't worry, I'll share the slide after so you can always react with them. If you click on it, it will direct you to link to GitHub. So you have this page. It's very easy. Just fill in your email and you'll be cool. All right, so we have demo two. So in demo two, we'll be creating, yeah, we'll create a new repository and we'll manage that repo. So earlier, I just created a repo on my local computer and I pushed it to GitHub, right? That was what I did. But now we'll create that repo on GitHub, would add files, would create few files, then we'll upload few files, maybe one of each. Then lastly, we would clone that repository. Remember we talked about clone, right? Cloning, you are getting those files from GitHub, the cloud, to your local machine. So we would also do that to see how that works. So let's see that. So I'll share my screen again. Just stop presenting. All right, so I would share my browser. All right, so let's create another repo. Again, if you don't have a GitHub account, just click on the link and you'll be cool. So I'm clicking on a new repo because that's what I want to do. So I'll select a new repo. So creating a new repo, you can read through this. I'll just explain things how it goes. You could create a new repo from a template, but in this case, I won't do that. So let's say we'll have a repo name. Yes, that's compulsory. A repo name, let's say event demo, because we've used live demo already. Yes, you can have you can have multiple repos with the same name, and then you saw me, I don't think you can do space. Yeah, spaces. Okay, spaces allowed. Yeah, but it turns it to hyphen. But I prefer this, so I'm going with that. Then yes, you could write, you should actually write description. It's kind of, yeah, it's advisable, right? To make someone understand what's your project, right? Then you get to choose if you want a private repo or a public repo, just as the name implies. Public is open to anyone, private is private. Only you or people you invite can collaborate on that. And just to emphasize, when you use GitHub Action, but I don't know if we'll talk about GitHub Action because of time, but Action is used to automate stuff. So if you use it on private, then you'll be charged. Like you'll be charged. It's not free. But when you use it on a public repo, it's going to be free. You won't be charged. So that you should be careful of that also. Then remember we talked about this file, adme file. So this is quite it's quite should I say important? Yeah, you should add it most of the times. In fact, all of the times to explain your project and all of that. I think I'll be uploading I think HTML. So let me just find HTML should not have git ignore, but let me confirm HTML. Yeah, there is no. Let me just go with Node. Actually, just a few little JavaScript on that project, but let's just go with that. Remember, I said this git ignore file tells GitHub what to exclude while or pushing your code to GitHub, right? So that does that. Then for the license, I'll just go with MIT license. Then I'm done. I'll click on this button to create my repo. I know I'm actually going fast because I'm trying to save time. I'm trying to save time. So if I'm going very fast, don't worry. You should get the recording of this event, so you can rewatch and pause and practice along. You can even take all of this demo to practice also. All right, so I've just created a new repo. So this is that repo. Um, Earlier I was talking about a link to that repo. So if you come here, you click on local, then you see this link. So this is the link to that repo. That other link I added to that my command line argument. So I could have gotten it from here. In fact, it's the same thing as this link. So you can get it here too. So that's how to go about that. All right, so our repo is up. Yeah, this is that README file we're talking about. So it has my repo title and my description. I should write more about this, but if I let's even do that. Since we are talking about uploading files, so let's do this. So let's add more, maybe just few more lines. So this is a markdown file. So I could, I don't have much to write because this is an event demo. So I'll just say MLSA events, that's just what I'll add. Then remember we talked about commit. So I'm going to commit my changes. Then because I'm using GitHub, right, the cloud version now, it automatically suggests my commit message. So I could change this to anything I want, but this sounds like what I just did. I just updated this, so it's cool. So I can add more description here. So I'll just say dot 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 because then um I can choose to commit directly to my main branch or create a new branch. For this, okay. You know what? Let me actually talk about this because this is like the essence of what we were talking about, right? I know this project, this repo is not complicated yet. It just has a README and few pictures, so there's no code that can be broken, right? But assuming you are working with a real code base, you shouldn't do this. You shouldn't commit your changes directly to your main branch. Remember, we talked about that you could, while trying to implement your idea, fix that bug, you could break your code. So instead of doing that, you want to choose create a new branch, right? So you are creating a new branch from that main branch that is having your new changes. So you could call this branch anything. This is just suggested, and I'm going to leave it as this, but you can change it. Then I'm going to propose change. So when I propose change, um, I would I would be um I'll be prompted, okay, this is what I just filled, update and this. But the interesting thing is this point, right? This place says able to merge. Remember, we talked a bit about merge. So for you to be able to merge a file, remember this readme file, just add my add the name of this repo and just one line of description. Then I added another line. So that is like there is a conflict, like there is different, right? So that is why we are able to match. Assuming there is no conflict, then there won't be any point to match because there's no difference, right? That makes sense. So that's the idea here. So there's difference, so we can match. So I can write more, if I was collaborating, if I were collaborating on someone's project, I would actually write more meaningful and explicit stuff here. But because it's just my this little stuff, then I really don't want to do that. So the interesting thing here is I can click on this create pull request. So we talked about pull request when we were explaining the workflow, right? So yeah, and this was GitHub Actions that I mentioned earlier. So that was automatically checking if branching could be performed, right? Remember, there has to be conflict. So now that sorry, I mean there is no conflict rather, but there has to be difference, right? So merging can be performed. So I can go ahead to to merge because I'm like the only I'm the creator of this repo. That is why I have access to do all of this. So assuming I am not the creator, then this would have to be reviewed, right? The owner would have to review my changes. Does it make sense? And all of that. Then if it makes sense and the person is okay with it, then the owner will be able to match the changes, right? So we talked about that when we were talking about the workflow. All right, so you see that your pull request is successfully merged and closed. So cool. Pull request is merged and closed, right? So I have this option. Remember, I said it's advisable. In fact, it is safe, like to always delete your branch when you merge, right? So I'll go ahead to delete that branch to avoid conflict or unnecessary duplication. So I've deleted that branch. So I can go back to my code. Now we would see that yes, this has updated because I made that change, right? So that's how to like manage your code, your repository. You can add stuff, edit. So we just okay. Just because I said I was going to create a file, so I would create a file. So I would create a new file. I would create just few lines of HTML just to demo this. So the interface is quite the same. From this top part here, you can choose the name. So I'll just say index dot HTML. So that will be my file name and extension because I know I'm writing an HTML file. So I use the extension. So I'll just go ahead to write few lines of HTML here. So HTML head. This is just because I really want to. It's not very important, but just because I said I was going to let me say demo page. So this is me writing HTML. Ideally, well, it's actually nice to write HTML. Yeah, it's not as bad as writing it in your notepad. So you still have all those autocomplete features. So it's still amazing. So you have body. my body, I'm just going to have a paragraph and say, hey, the canonical computer science word, which is hello world, right? So I'll type in hello world there. Then footer, I don't need to add footer. I'm done. I'll commit my changes again is suggesting commit message, which is nice. So I'll just do that. Again, I shouldn't do this ideally, but because I want to save time, I'm the owner of this project, and I also know that I've not broken any code. So I won't go ahead to do a new branch. I'll just do it directly here. I would submit that. All right, uh so here is the new file now. This is the HTML file. So we've successfully added the file. Now let's upload files, right? Let's say I have that file on my local PC, so I can still do that. So I can come all the way to code again. Then I would say instead of create new file, I'll choose upload from this end now. Then from here, I can choose the files I want to upload. I'll go ahead to my desktop. I think I have other images that I did not upload the other time. So I'll just add that and this. All right, so upload. By the way, GitHub has GitHub for mobile, it has GitHub desktop, and this is the website. So you could use anyone you just prefer. Again, I'm going with commit directly to the main branch, which is because this is a demo session, ideally. But if you know that nothing will be broken, also it's fine to skip it also. So we've added these other files, so you can also click on them to view them. So that's fine, that's working. So that those are the pictures we I just added. All right, so the next thing I said I was going to do was to, okay, you know what? Since we are talking about uploading, I would quickly, I'll quickly, should I, so let's do that. I'll quickly go back to my repo. In fact, I'll just, what should I do? Yeah, I would go ahead and delete all of these files because I want to push a code like a project I have um on my computer to the cloud. So if you have a project on your local computer, you could push it from like with the command line, but some people don't really like command line, so you can also do it without the command line. So I'll quickly show you how you can do that too. So if you know you're not very like if you know you don't like command lines, well, with time you will, but if you really don't like command line, then you could download GitHub for desktop. That would really be your go-to because you don't really have to write a lot of command lines if you are using that. So I'm trying to delete all these files because I want the repo to be empty. All right, hopefully I've deleted all. Oh, did I? Initial. Okay, you know what? I'll just create a new branch instead of um doing that, wasting time and all that. So I would say TG. Okay, let me even write it completely. Typing game. So the project I want to upload is a typing game. So I'm creating from main. No, not from main actually. You know what? It I deleted all of these files. Okay. Okay. I think it was I made a mistake. I didn't commit my changes. So sorry about that. So you actually need to commit your changes. So that was why those files not gone. Remember, commit is like you submitting those changes. So I deleted, but I did not commit. So that's not the practice. So even after deleting, you still have to commit. So that was what was causing the problem. So let me just delete everything. And this time, be careful to commit. All right, so this is the last one, I suppose. All right, so okay, commit this. All right, so my repo is empty again. All right, good. So what I'm going to do now is I'm going to upload I'll just go ahead to upload that project I talked about. So my desktop, I should have typing game. Yes, this one. Then I'll go ahead to what is that? Why is it empty? Okay, let me check that folder. Don't know. Okay, folder is indeed empty. All right, so let me quickly look it up. I know you might still be seeing that screen on, but I'm trying to find that project from my end. So that's where is it? Okay, it's all right. So I just copied that project there. So let me refresh and find it now. So typing game. Okay, I didn't delete the other ones. So it should be this. All right. So it has all my files. So I'll select all and just upload. Right, so GitHub has a lot of features, a lot of cool tools and amazing features. So there are a lot of them, and I'm sure we cannot talk about all of it on this call. So I'll just talk about few. So yes, add file. Let's say commit message, add typing game, because that explains. Oh, not supposed to do that. Okay, typing game. Add typing game, I can go ahead to do this. I'm again not going to do new branch because of time. Ideally, I should create a new branch. All right, so this is the project, and this is what a README file looks like. So it has info on the game. I think it even have a video playing the game. So it has instruction and all of that. So that's not so we are actually done with this other demo. So let me go back to my my I'll stop sharing that screen now. And I'll go ahead to share the slide. Yes, the slide. Oh, let's not do this. So I'll go ahead to I'll just stop sharing and I will go back to share the slide again. Yes. All right, so the slide should be up soon. Let's resume that. All right, so we just completed that demo. So let's proceed. All right, so I have okay, I actually did this kind of when I was trying to explain um yeah, when I was trying to explain you instead of committing to the main branch, you should create a new branch and all of that. So I have this practice exercise for you. On this link, you can click on this link. You would be directed to a GitHub repo. So you read through the instruction. There's a README page. There's a guide on how to complete the exercise. So your goal is to make your first contribution. Go out there, make your first pull request. Commit your changes, make your pull request, and hopefully your change will be matched to the main branch after it's been accepted by the repo managers or contributor or owner. All right, so that was a task for you. You should check that out. All right, so moving ahead, we have GitHub Codespaces. So what is GitHub Codespace? GitHub Codespace is an instant cloud-based development environment that uses a container to provide you with common languages, tools, and utilities for development. All right, that is like a mouthful. So what are we talking about when we talk about Codespace? So if you've ever worked on a project, maybe like say a project on Node.js, you know the stress of having to install Node, get your packages, get your dependencies, and all of that. So that is what GitHub Codespaces has come to solve. So you don't have to worry about your development environment. You can just use this cloud development environment that is already customized based on what you want to use. Like you could just select a cool space that is customized for React or Node.js project, or maybe some kind of Python project based on your stack. You could just select that, and you can even create your own. Apart from the customized one, you could create your own and just work based on that. All right, so at this point we have the timeline for GitHub Codespace, right? So everything begins with starting creating a code space. So that's the first step. You create your code space. At some times you might need to rebuild. Maybe you might need to rebuild your code space. Maybe you got disconnected or network issues. You might have to rebuild, or maybe you changed your what is it called, yeah, your virtual machine. You changed your OS, yeah, your operating system. You you need to rebuild, and then you should stop your code space when you are done using your code space. And then you should stop your code space, and finally you should delete your code space. So that's ideally the lifespan or timeline of GitHub Codespace. So when you create a Codespace, you four process occur. Virtual machine and storage are assigned to your Codespace. A container is created for you. A connection to the Codespace is made. A post creation a post creation setup is made. Yes. So all of that is done for you when you create a code space. You have VM. Actually, code space is if you are familiar with running virtual machines. So when you're using code space, it's like you using Virtual Studio Code on a virtual machine. And if you've not used a virtual machine, it's just a computer on the cloud that you have access to for some period of time. All right, so ideally, when you are done with your code space, you should stop and delete that code space, because if you don't delete your code space, you'll still be charged for storage costs. Yes, you still be charged for storage costs, because you still have to store your files and all of that. So ideally, you should delete your code space after you are done with it. And um when you're using code space on the web, autosave is automatically enabled. Unlike when you are using Virtual Studio Code, you have to enable that. And when you exit your code space, like maybe you closed your browser, or the browser is just left idle, your code space will time out about 30 minutes or so. But I think you can customize the timing. So emphasis on you should delete your code space again. You should really delete your code space after completing your project. All right. Another picture we'll be talking about, which is the final one, is GitHub Copilot. All right. So GitHub Copilot is the world first at scale AI development tool that can help you write code faster with less work. GitHub Copilot draws context from comments and code to suggest individual lines and all functions instantly. So you can access Copilot with the chat option, or you could access Copilot using the comment syntax within your code, and you get suggestions from Copilot. Copilot helps you, it writes codes for you based on your comments. It gives you suggestion when you are typing, kind of auto suggest what you could be your what you could be typing, figures out those, and suggest those along the way for you. It's actually a wonderful experience. Working with Copilot is like having a partner with you. You It's like you having a partner you're working together with, and it's really helpful. So Copilot features. So you have that chat GTP like experience right within your code editor with Copilot's chat, or remember the comment syntax also. So you get AI generated answers about documentation. So you could use Copilot to come up with documentation instruction for your project. You could also use another feature of Copilot would be for command line. Yes, Copilot for the command line interface, CLI. And you could also use Copilot for pull request tags. Yes, tagging your pull requests appropriately. So Copilot will suggest those. So to install Copilot, you have to add Copilot extension in your Visual Studio Code, then enable Copilot in Visual Studio Code. If you look at this image, you would on your from the sorry from the menu, select preference and settings, so you can configure your Copilot from there. So you get to customize how you choose to react with Copilot. All right, lastly, I have a demo, but because of time, I think I would stop here. But the demo is actually cool. I'll just show you. You can access it on. Okay, let's see. So this here is the link to the demo. It's a GitHub repository. So we want to use Copilot and Codespace.